Glaciology is the study of ice, but in particular glaciers and how they move and discharge ice into the ocean. And so when you're trying to make projections of how sea level rise might occur in the future, you need to understand sort of the physics or the math that give rise to how fast ice moves and how fast it dumps ice into the ocean. My role in the project is to try to understand processes of how things might change at the ice bed interface of glaciers. So that's right where a glacier sits on its bed. And the way we do it is, in particular, we build machines. So that's not all we do, but we build big machines that can simulate what's happening specifically at the ice bed interface. And that provides us another context to try to explore these fundamental processes and how you might perturb the system to alter ice flow in a laboratory setting that doesn't have all the complexity of the real world and all the implications of trying to manipulate the real world.
Ice sheet models are our main tool to project how in about 100 years, for example, sea levels are going to rise due to extra ice discharged into the ocean. So if you think of a water glass and you put extra ice cubes into it, obviously the water is going to roll over, or drip over at some point. And the same is true for the ocean. You add ice into the ocean and sea levels are going to rise. Now, how much ice we are going to add into the ocean, we have to rely on these complex models to project. And so by finding better ways of what's called parameterizing certain processes in the models, so of representing certain physical processes into these models, we can make these models better and ultimately then get a better handle on what is global mean sea level rise going to be in, for instance, 100 years. And then that obviously relates to flooding, because the question of how often the place floods is directly related to how high is the sea level at that place. And we are not only talking about the constant rise in sea level, but also about things like high tide flooding, which can become way more likely when sea levels rise.
It turns out that the bottom of these Antarctic glaciers have such high water pressure that they're basically floating the glaciers off the bed. And that's why gravity is really efficient at moving lots of their ice into the ocean, because of this high water pressure. So the theory is, if you were to drill through the glacier and you were to suck out some water, that would lower the water pressure and that would more tightly couple the glacier to its bed. And that improved coupling of the glacier to the bed would make it move or slide or slip slower than it would be if the water pressure was higher. And so what our project is aimed at, or one of the goals, is to build a new one of these devices. So right now we have one marine shear device, and it's currently the only active one in the world. But to build a second one so that we can explore more of these fundamentals, more of these processes. And in that experiment, what we would do is slide like we normally do, but then partway through the experiment, extract water from it, just like you would propose in the real world, and see if it actually works, or does it have adverse effects that people haven't considered.
The goal of our project is really to improve these equations that go into these models, and then ultimately directly improve the models and the sea level rise projections. And so I think if you live close to the coast, the difference between 0.5 meters and 1 meter sea level rise is quite big, right? And it might be the difference between being flooded once a year and being flooded once every 10 years. And that might ultimately decide whether you want to move or whether you're comfortable staying. Because the question on a personal level is always, what is the risk that I'm willing to accept? And so even though the research itself is very fundamental, the hope is that it contributes directly to better projections that help make policy decisions, but also individual decisions.